let's finish up the solution to this problem. So I've in the previous videos explained how we can figure out what the mass flow rates are in each stream by using a for loop. But we're not finished, because what we actually need to do is we need to find the mole fraction and the mass fraction of our stream 2. And we haven't done that yet. So how do we find the mole and the mass fractions? Well, the mole fraction is just the moles of component I, for instance, divided by the total molar flow rate. And so we need to find a way of figuring out what the total molar and mass flow rates are of our stream. The mass fraction is the same thing, the mass of I over the total mass of the stream. So one easy way to do it is by using a built-in function called sum. And sum will sum up all of the elements inside a vector. So if I write m total, then I could write sum. What am I going to sum up? I want to sum up all of the elements inside m. This m variable that I've created now contains, after this for loop, this m variable contains all of the mass flow rates, the individual mass flow rates for our component streams. So if I write sum of m, then that will find, it will sum up all of the numbers, all of these numbers here actually. 2178 plus 2499 plus 4807, and so on and so on. Add up all of those numbers and give me the total mass, and I guess as a demo I can type it in here. Sum of m will give me the total mass flow rate of the stream. So if I write it as a variable, I can create a variable called m underscore total, or tot, to represent the total mass flow rate of my stream, and n is, or n total is the sum of n. And now I'm done actually. Now I've got the total mass and molar flow rate of my stream, so I can find the mass fraction and the mole fraction of all components in my stream. So remember, m, or m, small m, is a vector containing all of the mass flow rates. If I divide this 50 by 1 matrix by a constant, then I'm going to actually divide each element by that constant. So if I typed m divided by sum of m, then that would give me actually the mass fractions, correct? These are the mass fractions of my stream, because I've taken each element inside my matrix and I've divided it by the sum of a constant. So I've divided it by a constant, which is a sum. Okay, and so then I've made this a mass fraction. And actually, if I sum answer, it should give me 1, which means that all the mass fractions equal 1. So that's just something that's happening that I wanted to describe. So what does that mean? It means that I can make variables called mass fractions, and that could be just the vector m divided by m total. Mole fractions is n divided by n total. And now we're done actually. If we run this, so I'm going to save this and I'm going to run it. I have created more variables now to hold the totals and the mass and mole fractions, and I've found everything that I need. So well, let me try mole fractions too. Mole fractions, yep, here they all are. And so to make it just a bit easier to understand what's going on, let me display it nicely. So I use the disp function to do that. I can say I want to make 3 messages that each print out the mass flow rates, the mass fractions, and the mole fractions of my stream. So the disp function just displays text or variable values to the command window. So let me write the mass flow rates. So mass flow rates, like that. That will print out, or if I run this now, it will just print out mass flow rates, because I haven't actually displayed what the mass flow rates are. So let me say disp m, save. If I run, then it gives me all the mass flow rates. Nice and neat. Maybe I want to put in units. I think it was grams per hour, G per H. Yep, and that gives me a nice little message. But let me go and copy this and paste it to say mass fractions and mole fractions. And then obviously I must display the mass fractions, and I must display the mole fractions. So if I save this, I run it, now I've created a program that works out the mass flow rates, the mole fractions, and the mass fractions of my 50 component stream, and then it's also formatted it nicely for me in a nice message to the user that can see what's going on. So I guess I could make this nicer. I could put in almost like a table format and put in component 1 and 2, but you get the idea. I've created a program that does a lot of work quite easily, and then it displays the results nicely for the user. So that's it for this video. I might make another video to show how we can turn these things into for loops themselves, just to show you how we could achieve the same result with more for loops, and to give you more practice using for loops.